All right, welcome back for another one. Title today, same as one yesterday. We're kind of splitting this section into two parts so we get the year going. Statistical and critical thinking. Huge word here, and you need to really get this down. Statistical significance, even put it in red. Basically, something is statistically significant or important if we get a result that is very, and I mean very, unlikely to happen just by chance. If something happens that's really weird, it doesn't happen just by chance often, that probably has statistical significance. Like I'm talking like less than 5% usually. For example, getting 98 girls and 100 random births, that would be statistically significant because that's very likely to not happen, very unlikely to occur just by chance. Getting 52 girls in 100 random one is not statistically significant because that could that's going to occur a lot probably, just 52 out of 100, because that's very close to, you need to expect 50-50. It's not often going to be 50-50, but 52, pretty close to 50, so that can very easily happen by random chance. To be statistically significant, it has to be very unlikely to occur just by chance. Okay, this is a little bit different. Practical significance. Sometimes something can be statistically significant, but common sense, don't forget to use that. Common sense says even though it's statistically, that's easy for me to say, significant, it still doesn't make enough difference to justify it or to use it. I got an example here on the next slide. This is I'm not going to read the whole thing, but it's 40 people in a weight loss program by Atkins, and did it for a whole year, and the average weight loss was 4.6 pounds, which that's not bad. And if you use methods we're going to use later to figure out if it was statistically significant or not, it is. I mean, losing that much weight, even though it's just 4.6 pounds, statistically is pretty good. It's significant because most people don't do that, so not likely to occur just by chance. However, use your common sense. Common sense says, okay, they did this for a whole year and lost 4.5 pounds. That's not that great. So even though it was statistically pretty good or significant because it doesn't occur just by chance, practically not very significant just to lose 4.5 pounds if you're going to be on a diet for a whole year. So hopefully you see the difference right there. That's a really good example, and I hope that makes some sense to you. All right, now we're going to look at some problems people run into when they do surveys or try to gather data or look at it or try to analyze it. The first one is they make misleading conclusions. This is the third video, and this is the second time that sentence has been in there. Just because two things are shown to be related to each other does not mean one causes the other. Smoking and pulse rate are related to each other. If you do studies on them, people who smoke, it does affect their pulse rate, or I can't say it that way. It doesn't cause an effect, but they're related. And studies show they're related, but you cannot statistically say smoking causes your pulse rate to change. Second one, reported results. That's just believing what people tell you is truth. I'm going to go back to weight loss. If you ask somebody what they weigh, a lot of times people tell you what they wish they weighed, or they'll go down 5 pounds. Like, for example, this morning I weighed 182 pounds. So I'm going to report, well, I weigh 180. That's what people do. So you don't get exact results just believing what they tell you all the time. Small samples is a problem. If you're going to do a study, you need to make sure you study enough people. I saw one study, they interviewed 3 people, and 2 people had leaned one way. So they said, hey, 67% of the people in this study did this. Well, it's only 3 people. So you got to make sure you interview enough people, and we'll talk about that later as the year goes on. Number 4, using loaded questions. This is basically, if you look at these 2 questions I have here in yellow, they're basically asking the same thing almost, but look at the different responses. 97% of the people said yes to this. Should the president have power to veto to eliminate waste? So when people think it's a good thing, like eliminating waste, they're like, yes, he should have that power, 97%. But then if you ask the same question, should the president have power to veto or not, just to have that power, only 57% said yes. So if it helps them, a lot of times they answer one way. So loading your question up can definitely affect the kind of results you get. Number 5, non-response. Some people just refuse to respond to surveys, or sometimes they're just unavailable. And so sometimes studies are flawed because some of their thoughts or answers could have changed the results. Sorry about that. Missing data. People do studies A lot of times low income people are left out. Homeless, what about them? It's hard to reach everybody. So sometimes there's data missing that would cause problems. Incorrect use of percentages. Guys, 100% is all of it. Can you really improve by over 100%? I was reading this one advertisement that says Continental Airlines ran an ad claiming that losing baggage, we've improved that area 100% in the last 6 months. They've improved losing baggage 100% in the last 6 months. Well, the New York Times said, and they were correct, they put, well, 100% improvement means no baggage is now being lost. And that's not true. So I get what they were trying to say, but be careful when you start using percentages or you see people using percentages over 100 to make claims. All right, last thing here. You should know all this already. Just a quick review. Math of percentages. To find a percentage of something, you just drop the percent sign, divide by 100. So 6% would be 6 over 100. So 6% of 1,200, you do 6 over 100 times 1,200. You could also change it to a decimal if you want to and just punch in your calculator. You get 72. To change a fraction to percent, you just do what the fraction bar tells you to do. You do 3 divided by 4, you get 0.75. Multiply by 100, make it 75%. Decimal to a percent, you just take that decimal, multiply by 100%, or just move the decimal over 2 places. That's how it's usually taught. Just move the decimal 2 places. Percentage to a decimal, just take the percentage sign away, divide by 100, and do your division. 85 divided by 100 is 0.85. Or also people just teach it, move the decimal back 2 places. So either way is fine. Move the decimal or do your division by 100 is good. So hope this made some sense. We will work on several problems dealing with this kind of stuff tomorrow, and look forward to seeing you then.